All right, hello everybody. This video is about composite functions, and in it we're going to be talking about the language of what it means to be a composite, and then working through doing some of the problems. So composite functions are created when you take one function and you place it inside of the other one. It's like substitution for functions. When you substitute that whole value in, the whole function in, what you create is a composite. So f following g of x. This right here means that we have a composite combined of f and g. And that little dot there, that is a symbol that means following. Okay, so that means that this reads f following g of x. Okay, so now if f is following g, which one comes first, f or g? G does. All right, so when we're doing composites, we need to move from the left to the right. The first thing here is that the x is inside of the g. Okay, so first the x is placed inside of the g, and then the g is what is placed inside of the f. So we move from left to right. Okay, now you've seen it written like this. You may have also seen this in the past written like this. Okay, now you can see that the x is inside of the g in this parenthesis, and then the g is inside of the f in the larger parenthesis. All right, so this is equivalent to that. That's what that means. Now, look at it the other way around. Now, the f is inside of the g. Okay, so the f has been plugged into the g here. And again, we could write this as g of f of x. All right, so let's look at an example of solving some of these. All right, so if I tell you that f of x is 3x minus 4 and g of x is x squared minus 2x plus 6, can you find f of g? Can you find g of f? Can you find f of g evaluated at 1? All right, let's find f of g first. So this is f followed by g. F followed by g. So we're going to take the g function first, and we're going to plug it inside of the f function. So we're going to take our f function, which is f, and inside the f of x, we're going to replace all of these x's in here with what we have here for g of x. G of x is going to go inside. This equals 3, and then I have times x, but instead of times x, I'm going to put this whole thing right inside there like that. Then I still have to follow the rest of this function. So I have the 3, I have the times this whole x, now I have minus 4. Okay, so now I can distribute the 3 and combine like terms for the final answer. That was 18 minus 4, which gives us 12 for our final answer part here. Okay, great. Now let's reverse it and see if we can find g of f of x. So now this time, instead of plugging in the g, we have the f that's second. The one that's second is plugged into the one that's first. So I'm taking this f and I'm plugging it into g. All right, so I'm going to take my g function, and every time I get to an x inside of this g, I'm going to replace that x with the f of x function. Okay, so let's start writing out the g. The g has x squared. So instead of the x, instead of saying x squared, I'm going to put in what I have for x here. My f of x is 3x minus 4. Okay, and then I keep following along my g. I have minus 2, and instead of x, I have to plug in this whole thing, 3x plus 4 again. Okay, and then I have plus 6. So let's put plus 6. Okay, so now I have 3x plus 4 squared. That means that I'm going to have to multiply this out using FOIL. Okay. Now this part I can just distribute the negative 2, FOIL this out, first, outer, inner, last, And sorry friends, I had that copied wrong. That should have been a minus 4, just the same as it is up here. All right, and then last step, let's combine like terms for our final answer. Okay, first, inner, outer, last, and then I had brought these parts down, and now we combine like terms for our final answer. Great. And now let's see if we can evaluate f of g of x at 1. There's two ways to do it. We could find find g of f first. All right, and since we already have g of f right here, that's probably the easiest way to go. We can just take this g of f that we already have and substitute the value 1 in for x. 9 times 1 squared minus 30 times 1 plus 30 gives us 9. Or instead of finding g of f first, we could have plugged in 1 first. We can plug 1 into f. And when I plug in 1 into f of x, I get -1. Then I have to take that 1 and plug -1 and plug it into g. And either way, we get the same answer of 9. Great.